strange sounds coming from Starliner. A huge asteroid rolled Ganymede over onto its side. And China announces when it'll try to grab a piece of Mars. All this and more in this week's Space Bites. Once again, astronomers detected exactly when and where a small space rock was going to crash into the Earth's atmosphere. Now, the object was designated as 2024 RW1, and it's a 1-meter asteroid, which was careening towards the Earth. And a few hours before it actually collided with the Earth, the Catalina Sky Survey detected it and sent out an alert to this astronomer network. And then people were able to make follow-on calculations and predict that it was going to strike the skies above the Philippines. And so then astronomers went outside, turned their cameras to the sky, and at the right time, a giant fireball appeared in the sky and went across from horizon to horizon. Unfortunately, there was partial cloud cover, and so we don't see this sort of super bright fireball, but you can see it going behind the clouds. But this is incredible. If you've never seen a fireball in the sky, one of these super bright meteors, they're once in a lifetime, a couple of times in a lifetime. To see one that's a meter across burning up in the atmosphere, that's once in many lifetimes. But now we can know with several hours notice when one of these things is going to happen, and then you could drive to the appointed location and watch the sky. Although you probably want the right size because, the Chelyabinsk meteor was 18 meters across, and that caused a significant amount of damage. So we got to sort of get the exact right size. But it's amazing that we can predict when these asteroids are going to hit the atmosphere and then to go out and watch them, both personally and scientifically. And this is the 9th time that one of these asteroids has been tracked and accurately predicted where it's going to strike the atmosphere. And this is just the beginning of an entirely new weather forecast. A giant asteroid shifted Ganymede. Ganymede is the largest moon in the solar system, one of Jupiter's 4 Jovian moons. And it's seen some things. Specifically, when NASA's Voyager spacecraft visited the Jupiter system back in 1980, they saw this strange feature on the surface of Ganymede. It's this region of concentric rings, of cracks in the surface of Ganymede. And then they later estimated that this had to be caused by some enormous asteroid impact into Ganymede, probably about 4 billion years ago. And researchers think that this asteroid was probably 20 times as big as the Chelyabinsk impact. That was about a 10-kilometer asteroid, so this was probably closer to 200 kilometers across. But what's interesting is that this asteroid impact is on the opposite side of Jupiter. Ganymede is tidally locked to Jupiter. That's a coincidence. Well, researchers now think that in fact that asteroid did not hit the exact opposite part of Jupiter, but instead struck it at an angle, and that caused Ganymede to roll over in its orbit. And then over time, it tidally locked to Jupiter again, so that now it only shows one face to Jupiter at all times. And the way that impact unbalanced the shape of the moon caused it to end up in this strange configuration. A strange sound coming from Starliner. Man, it really sounds like the Starliner capsule is really cursed. So a couple of days ago, astronaut Butch Wilmore, he was one of the astronauts who flew to space on board Starliner, was listening to strange pulsating sounds coming out of the Starliner, like it was haunted or something. This was interesting. He recorded the sounds, and then NASA did some follow-on investigations.
I'll do it one more time, and I'll let y'all scratch your heads and see if you can figure out what's going on. Here we go.
It turned out the sound was coming from one of the capsule's speakers, or some kind of audio feedback between the capsule and the International Space Station's system, and this was causing feedback, and they were able to isolate it and remove it, and it didn't cause any risk to anyone, and yet just like another thing that's weird. And of course, we've learned that Starliner is going to be detached from the station empty. They're going to get it away from the station as quickly as possible, and then they're going to do a re-entry to find out whether or not it would have been safe all along. And then the two astronauts, Wilmore and Williams, who flew on Starliner, are going to have a ride home on an upcoming Crew Dragon mission. China lays out its Mars sample return mission plans. Now, we've known for a while that China is planning a series of deep space exploration missions, the Tianwen series. Now, we already saw Tianwen-1. This was the rover lander that went to Mars. Now, it's no longer functional, but they were able to do some really interesting research to help produce a global map of Mars, be able to do some ground penetrating radar scans from the surface of Mars. And we've known that there are other missions coming. And Tianwen-2 is going to be a sample return mission to a near-Earth object, which is going to be really interesting. And this will build upon their work with their lunar sample return missions. They've done 2 so far, including one from the far side of the moon. So that's Tianwen-1 was Mars. Tianwen-2, that's going to be to a near-Earth object. So Tianwen-3, this is going to be their Mars sample return mission. And at a conference this week, the head of the sample return mission program announced that they're planning on launching during the 2028 launch window. And so then the mission will fly to Mars. It will go into orbit around Mars. It will send down a descent vehicle, which will land on the surface. It will choose a sample and then fly that back up into orbit, rendezvous with the return capsule, and then come back home to Earth. And so we're probably looking at about 2 to 3 years for the entire mission to get back to Earth. And so scientists will have a fresh sample of Mars in their hands that they can then study in the lab. And really the primary goal for Tianwen-3 is to search for life. And I think this is very direct of the Chinese. Like, NASA has been sending spacecraft after spacecraft to Mars to follow the story of water on Mars and building up with Perseverance to maybe look for evidence that Mars was habitable for a long time. The Chinese are going to go to Mars, grab a sample, bring it home, find out if there's life in it. That's pretty cool. And obviously, if they're going to be flying by 2028, there's almost no way that NASA is going to be able to fly its own Mars sample return mission by 2028. I mean, maybe if Starship gets flying and it proves that it can fly to Mars and land on the surface and take off again, and there's a way they can retrofit their existing Mars sample return mission plans to fit within, I don't know how they would do this. And so it looks like the Chinese, if they're successful, will be the ones to bring back the first sample from Mars. And then following on Tianwen-3 comes Tianwen-4, and this is going to be a mission to Jupiter. And we're pretty unclear on exactly what the mission is going to consist of, but it's probably going to be an orbiter that's going to explore the environment around Jupiter. They're thinking of maybe delivering an impact probe to Callisto, which would then crash into the surface of Callisto and throw up a spray of debris that could then be analyzed. Similar to what happened with, say, the DART mission or the L-Cross mission that struck the moon a few years ago, or Hayabusa 2, which sent an impactor into an asteroid. And so that's 2030. And so those are the plans for China's deep space exploration in the coming years. Every week, we do a vote on our channel where you tell us what you thought was the best story of the week. And the winner this week was the possibility that Betelgeuse has a secret companion star. So thank you everybody who voted on the channel. We post the new vote within about 24 hours to the community tab on our YouTube channel. So you can go there, find the vote, or if you're just scrolling on YouTube, the vote should pop up. Now, the best chance to be able to see the vote is to be subscribed to our channel, click on the notifications bell, and then you've got to watch a bunch of videos to train YouTube that you want to be able to see these votes. A new way to detect primordial black holes, but it's a long shot. Now, primordial black holes is one of those ideas, one explanation for dark matter that just won't go away. And there's no evidence that these primordial black holes exist. And if they did, they would have to have been formed at the very beginning of the universe. And yet certain sizes of primordial black holes could still explain dark matter, the extra mass that's in the universe that doesn't seem to interact with regular matter in any way. Now, we already have gravitational wave observatories here on Earth, and so Avi Loeb was wondering what would happen if one of those primordial black holes came so close to the Earth they could actually be detected by one of those gravitational wave observatories. He did the math, and it turns out that you would need to have a primordial black hole that weighs about 100 megatons. So that's a small asteroid coming within about 6,000 kilometers of the Earth, and it would have to be moving at relativistic speeds. It would have to have been accelerated through some three-body interaction with a star or a supermassive black hole. And yet if it came that close, it would cause a signal that was detectable by LIGO, CAGRA, Virgo, and we would have conclusive evidence that there are primordial black holes buzzing around the universe. Of course, a black hole with 100 megatons passing within 6,000 kilometers of Earth would have an effect on our planet. We would notice. And we have never seen that. It's never been recorded in the history of humanity, and definitely not seen in any of the gravitational wave observatories. But people have always wondered, like, what if these things were out there and what if they came close? Well, someone did the math, and we haven't detected them yet. Europe is sending a drill to the moon. So the European Space Agency is following the story of water on the moon. And in this case, they're going to be sending a drill and a science package to the surface of the moon. And this is like a great example of this commercial lunar program that NASA has set up, where you've got various projects that are just paying for the flight to the moon. They don't have to worry about the lander, about the rocket. They just pay for a fee to have their payload delivered to the surface of the moon. And in this case, Europe is paying for a drill that is going to be able to drill 1 meter down into the regolith to probe the temperatures that are below the surface of the regolith. And the hope is that they're going to go down about 1 meter and they're going to find that the temperatures are around -100 Celsius. And at that temperature, you're going to be able to get water be frozen into ice, and that ice would be protected from space radiation and the temperature of the sun by the regolith, like a blanket for ice made of rock. But Europe has booked a flight on an upcoming lunar lander mission that's going to be launching in 2027, simulating the accretion disk around a black hole. Black holes, of course, are invisible. They absorb all of the matter and energy that falls into them. Their gravity is so powerful that nothing, not even light, can escape the event horizon of the black hole. And yet we see them shining across the universe. And it's not coming from the black hole. It's coming from the accretion disk, this torus of material that is swirling around the black hole, kind of waiting to die, waiting to go in like a whirlpool when you empty out your tub. And this material can be crushed together and under such high temperature and pressure that it starts to act like the interior of a star. And so we see very bright X-ray radiation coming from these regions around a black hole. But it's an incredibly complicated place where you've got both this material swirling around, you've got the rapid rotation, the frame dragging of the rotation of the black hole, these intense magnetic fields that pierce through this accretion disk and cause all kinds of bizarre turbulence. And so researchers have spent a ton of supercomputing time to simulate what's inside the accretion disk, to see a 3D cutaway of what's inside the accretion disk. And in fact, there are waves that pass through the accretion disk. And so they were able to simulate how these waves move through the accretion disk. Now you're watching Space Bites, but what I'm doing right now is I'm writing my weekly email newsletter, which we call The Guide to Space. We've decided to give it a new name. So this, of course, is a gigantic breakdown of all of the top space and astronomy news stories that I'm tracking this week, a bunch more than we have time to cover here on Space Bites. For example, how dark oxygen could change our understanding of habitability, how an ancient galaxy merger will produce a very luminous quasar, and how a new test proves how to make the Event Horizon Telescope even better. So if you want to get this every week, it's completely free. You can just go to universetoday.com/newsletter to sign up. And let me know what you think of the name. All right, I'm going to talk about an interview that I just did, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Gilton, and David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, SpiderSwap.io, Stephen Krasaki, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I posted a new interview on the channel a couple of days ago about advances in interferometers and some really interesting ways that we could put interferometers on the moon, in space, on Earth. And it was an interview with Dr. Gerard Van Bell. He is the director of science at the Lowell Observatory. And he had just some amazing, really clever ideas about how we could, say, send a really tiny telescope to the surface of the moon with an upcoming commercial lunar mission and separate it by tens of meters and make one of the most sensitive telescopes that's ever been built. Ways we could build a telescope down here on the surface of the Earth, have an interferometer that is kilometers across. So if you missed that interview, I really think you should take a second and go and watch it. Listen to it, download it as a podcast, whatever you want. But I think you will find it wildly entertaining. It'll cause you to understand a lot better about how interferometers work, as well as some really clever ideas on how we can get to this inevitable space telescope. All right, let me know what you thought. We'll see you next week.